Hello everyone. In this current session we are going to discuss on Numpy. This is a fundamental package of Python. Numpy stands for numerical Python. So it is mainly for scientific computing. This package provides one ND array object that we are going to use very frequently. ND stands for n dimensional. That means this array can be, as you know, the array can be, so far we have used one dimensional or two dimensional arrays. Similarly, here I can create n dimensional arrays of homogeneous data types. That is important. That means when we are going to create array for this Numpy object, then it is going to take only a single data type. So I have to mention that data type. Okay, so it provides a multidimensional array object and it can have some various derived objects as well, such as masked arrays and matrices. We'll have some discussion with some hands-on, of course, and it provides an assortment of routines for fast operations on arrays. Actually, there are a lot of operations possible that you will see. We will show few of those operations on Numpy array that are very convenient and very easy to use. That includes some mathematical, logical operations, shape manipulation, sorting, selection of data, input output, discrete Fourier transform, basic linear algebra, statistical operations, and lot many things. Okay, so we'll go to Jupyter Notebook and try to create one Numpy array object. So now I am in Jupyter Notebook. So this is a file I have created for Python. So the first statement I have written is import Numpy as NP. So already we have imported this array library as well. Similarly, here I am importing this Numpy library and I am giving it a name as NP. So let us execute this. Okay, so I have included this. Now I am in the next block of code. Here you can see I have written a1 equal to np.zeros. It is again one function of np which is taking two arguments. First of all is the number of elements, that is 2, and then np.int64. that means I want an array to be created with 0 value with 2 elements and it is of type integer. So if I execute this, so you can see one dimensional array is created having 2 values, each is 0. Okay, so again it is another statement. Here I have called np.ones function. Okay, similar to the last one. So here again one dimensional array is created and having the values 1 in each element. So if you just want some test array to be populated with all zeros or all ones, so these functions will be helpful for you. Okay, so the next thing is, here you can see I have created 2 arrays. One is B1, another is B2. So let us first create, I will create another cell here. I will print this thing. I will just copy this part from this cell to the next cell. Okay, so here I have provided some list of values in the argument to np.array. Okay, it's another function which is going to create array, and here inside that first bracket I have provided a list of values. So let us create and try to print. So if you, once you have executed, you can see it is 2 arrays are created, B1 and B2, and there is an option that I can concatenate 2 arrays. So if I, so you can see here b equal to np.concatenate, and in bracket I have provided b1 comma b2. So if you execute this, so now you can see it's kind of a concatenation. So it was an one dimensional array, it is another one dimensional array, and once they are concatenated I got one dimensional array having 8 elements, 4 plus 4. Okay, next is np.empty. Empty is another function. Let us see how it works. So it is something some default values are populated here. So it's actually some array is created without any specific value. Now it is another array I have created. Here I have used one function called arange. This function will generate numbers less than 5. So ideally it should contain 0 to 5. So if I execute, so you can see it is 0, 1, 2, 3, 4. So arange, it is a range function which will start from 0 and excluding the element I have provided. Okay. Again I have another array. Now till now I have dealt with one dimensional array. Now it is an two dimensional array. So here I have created this, I have again called this array function, and as argument I have provided this nested list of two dimensional. Actually I am trying to create two dimensional array. So now you can see it is created. The first row has having 2, 3, 8, 4, second row having 6, 1, 7, 5. Now next function, it is np.sort. So as I told you that it's very simple to sort, so you can just call the sort method and the array will be sorted. So I have, if you execute this D2 now contains the sorted array. Sorted array means it has sorted row wise. So first the first row is sorted and then the second row is sorted again. Fine. So sort function works this way. Okay. Now there are three things, that is shape, size and dimension of an array. So D2 is an array. So let us first print these things, and then I have just done something else. So let me put it somewhere else. So I will create a new cell here. So if I execute this, you can see the shape of D2 is 2 by 4. You understand, 2 means the number of rows and this one is the number of columns. So it is a 2 by 4 matrix actually. Size of D2 means the number of elements, so that is coming as 8. Dimension means it's a 2-dimensional array, that's why 2 is coming. So these are three parameters which given by D2.shape, D2.size, D2.ending. Okay. Now there is one function which I can reshape the array. Okay. So now so far it is a 2 by 4 array, so I can make it 4 by 2. Okay. But you have to make sure that if you change the shape, but the number of elements should remain fixed. So if instead of writing 4 2, if you write 4 3, then it will give you error. So let us first try this. So if you execute, now you can see that this 2 by 4 array is now converted to 4 by 2 array. Okay. So if I try to make it something 4, 3, if you try, then you can see that it is giving some error message that cannot reshape array of size 8 into size 4, 3. So whenever you are reshaping, you have to keep in mind that the number of elements should be unchanged. Okay. Next one is, I am just keeping this np.arange I am calling, so it should be from 0 to 5 should be populated in E1. Then I have printed the shape of E1 and the array E1. So you can see here that the shape is, it is showing as for a one-dimensional array, the shape is showing as 6 comma. That means it is a one-dimensional array and the first dimension contains 6 elements. Okay. So this is the array. Okay, fine. So if I go back to my presentation, okay, so these are the features that we should know. First of all, it has a fixed size at creation. Okay, elements are of the same data type and of the and the same size in memory. Of course, as the each element is having the same data type, that's why the size of each element will be same in the memory. Numpy arrays facilitate advanced mathematical and other types of operations on large numbers of data. We will show you some of the operations that we can do on the Numpy array. Typically, such operations are executed more efficiently and with less code than is possible using Python's built-in sequences. So far we have used list so far in many of the examples, but the NumPy operations are more efficient compared to the list or other built-in sequences of Python. Okay, so actually it is a very powerful library, as I told you, and its functions are very efficient. They work very efficiently, and there are two more things that is being talked about the NumPy, that is vectorization and broadcasting. We will come back to that, but let us continue in the Jupyter notebook only for now. Okay, so increasing the array dimension. Okay, so whatever may be the dimension of the array, so I can change it with this function np dot new axis. Okay, so if you remember here, this e1 I had created, it was an one dimensional array. So if I just change it, so here I have written e2 equal to e1, and here I have created a new axis. Okay, so if you just execute this, so you can see that it is showing something differently. Earlier it was 6 comma, that's it, and it was only one list of elements, but here now it is shown differently, that it's a one row and 6 columns kind of. Okay, so a new axis is added in the first part of the dimension. And if I do it differently, if instead of doing in the row part, if I add it in the column new axis. Okay, so I am creating e3 from e1 only. e1 is a one dimensional array, so the shape is something like that, 6 comma. So if I try to do this, then you can see it is showing 6 comma 1. 6 comma 1 means actually the number of elements are fixed here, but how it is represented, that is the different thing. So here the shape is 6 comma 1, that means there are 6 rows and 1 column. In the earlier one e2, it is 1 row and 6 columns. So you can understand that when e1 was created, it was originally it was only having one dimensional array, it was one axis, but now I have a new axis and it is represented this way. So you can see e3, it is having 6 rows. Here each row has 1 column. So that's how I can increase the dimension of the array. I think clear so far. Next part is indexing and slicing. So indexing and slicing we have already used for list, and it is more or less the same here also. So we have few example programs. So first one is, I have created one array np dot arrange 8, and I will print. Okay, let me see. I just wanted no, it's fine, let it be. Okay, so here I am printing a0 and then a1 colon 4. Okay, and then another print statement I have written, where I have written a, and then in bracket, in the square, inside the square bracket, instead of providing index or a slice, I have provided one condition. So let us see how it works. For simplicity, I will print a as well at the starting. Okay, so I will execute. So here you can see a is this. So it is an array which is starting from 0 and the end value is 7, and the next print statement, it is printing a0. So as expected, it is the first value, 0 is printed, and then a1 to 4. 1 to 4 means, you know, that the first value in the slicing is included and the second one is excluded. So you should get the value from index position 1 to 3. 1 to 3 means this is 0, so this is 1, 2, 3. So I am getting that as output, and then I have this. So here I have written print a, inside the square bracket I have provided one condition, a less than 7. It does mean that all the values inside the array having value less than 7 should be selected. So that's why it is something like that. Okay, if I just change this condition, suppose if I write a greater than 5. So if I execute this, now you can see that from all the values only 6 and 7 are greater than 5, that's why they are printed here. Okay, fine, I will keep it as before. Okay, and then the next one is I have created another array. Here I have called the array method of np, and this b is created. I can just print b, and I will add this in a next cell. Okay, so I'll just run and print. So here you can see this is the B array, and the index positions, you know, it is something starting from 0. So 0, 1, 2, 3, 4, 5. Okay, so now I have called one function called non-zero. So this function, inside the bracket I have provided b less than 7. What does that mean? B less than 7 means it will compare in the B array that which are the values having the value less than 7. So here I can see that there are 4 values who are less than 7, 1, 3, 5 and 6. Okay, and when I call this non-zero method, so it will return the index position of those values which are having this, satisfying this condition. Okay, so if the index positions need to be returned, so it should be 0, 1, 2 and 5, right? So if I execute this, so you can see it is returning one array having this index positions as elements, and the data type is integer. Okay, so this is one method to get the index positions of some values where some condition is satisfied. Okay, our next topic. Okay, then I am going to now create arrays from existing data. So we are going to discuss many of the things. Actually it's a very powerful library, as I told you. So okay, so here what I am doing, so I am calling the arrange method. Here I have mentioned the start value of that range as well. So as you know, if the start value is not mentioned, then it will take 0 as the start value. So here I want 1 to 17, that means all the values from 1 to 16 will be printed. Let us see. So 1 to 16 values are printed. Okay, in the next line what I am doing, A1, and then I am doing the slicing from 0 to 8, that is all the elements from index position 0 to 7 will be taken. So 0, 1, 2, 3, 4, 5, 6, 7, right? So these many elements should be taken. So these are actually 8 elements, and I want to reshape it as 2 by 4. Hence I want 2 rows and 4 columns. Let us see how it works. So now if you print, you can see 2-dimensional array is created having 2 rows and 4 columns. So total 8 values. Next I am doing here again the same type of operation. Here I am taking starting from 8 position and end is blank, that means it will take till end of the array. Okay, and then I am reshaping to 2 to 4, the same thing. So if you do, you can see that now I have 9, 10, 11, 12, 13, 14, 15, 16. So again 2-dimensional array. So this A2 is a 2-dimensional array, A3 is a 2-dimensional array again. Okay, now I have one function. Actually there are 2 functions, one is vstack and one is hstack. So vstack means it is vertical stack, means it will be like on one array. So as there are 2 arrays, I am doing the vstack on 2 arrays, so it will be put just one by one. And horizontal stacking means it will be just beside one. So it is like A2 and A3. So you can see, if I execute this, then it will be better to understand. So now you can see it is A2 and A3. I am doing the V stacking. So it is something like 1, 2, 3, 4, 5, 6, 7, 8, the first array, and then the next array is just appended, it's below. So it's a vertical stacking, it's called V stack. And then I have this A5 equal to np.h stack. So now here I am doing the horizontal stacking for A2 and A3. If you run it, now you can see that in the earlier case I had 2 rows plus 2 rows 4 rows, but here I have the number of rows remain fixed, but 4 columns plus 4 columns, 8 columns in each row. So, it is something like first of all 1 2 3 4 and then 9 10 11 12 are appended horizontally. So, I have some 2 by 8 array, and in the first case I have some 4 by 4 array. Okay. And there is another function called hsplit, which can do that I can horizontally split any array. So, here I have written A6, A7, A8, NN and np.hsplit A1. I am trying to split A1 in 4 portions. So, if you execute this, you can see that actually 4 arrays are created now. Okay. So, this was the entire array, and now 4 different arrays are created. So, it is so far clear, I guess. Okay. So, whenever so far most of the operations we are doing, it is called the shallow copy. Shallow copy means when I write something, when I write some command on an array, then actually one copy is created, but that copy is called shallow copy, and if I make some change in the array in the copy, then actually it is the original array is also gets changed. Okay. I will try to explain it. So, suppose I will create another cell here. Okay. So, let us print A1, print A6. You know that A6 was created from A1 only. So, if you execute this, you can see that A1 is the array with some 16 elements, and A6 is having the 4 elements, right. So, I had created it with the hsplit function. Okay. So, now I am trying to change one value in this A6 array. So, in the 0th position, that means the first element I want to change it to 0. So, what I expect that it should be 0 2 3 4, but I am not making any change directly in A1. Okay. So, if you execute this, now please check that this A6 is changed and A1 is also changed, because A6 is a shallow copy of the original array A1 and they are actually linked, and whenever you make any change in the copy, then the original object is also changed. So, if you do not want that, then we have to go with the deep copy option. Deep copy means if I want to make a copy of an array to another array, but I do not want to make any change reflected in the original array when I am doing it in the copied array, then I can use this copy function. Okay. So, here I can see I have created a new array called B2 from A1 with the copy function. So, let us execute this first. So, you can see that B2 and A1 are printed and both are same to same, because B2 was copied from A1. So, now here I am trying to change the B2 0th element to 1. Okay. And if I print, now you can see that for B2 the 0th element is changed to 1, but for A1 the 0th element remains the same. So, in case of deep copy, the original array is not getting changed. So, you should be careful. Based on your requirement, you should go for either shallow copy or deep copy. Okay. Next one is our basic array operations. So, we can do this arrange and reshape we have already used, and then I can do A3 equal to A1 plus A2. So, it is like it is kind of a matrix addition, you know. So, here you do not need to write lot of code, it is only simply I am writing A1 plus A2 and it actually works. So, if you execute this, so you can understand A1 should contain something 1 2 3 4, and it will be a 2 by 2 array. A2 is starting from 5 to 8, 5 6 7 8 means 4 elements in A2, and the shape will be 2 by 2, and A3 is A1 plus A2. Let us check how it works. So, you can see this is my A1, this is my A2 and this is my A3, simple. matrix addition. So it's kind of a 5 plus 1 6, 2 plus 6 8, 3 plus 7 10, 4 plus 8 12. So it's very easy to do matrix addition with Numpy here. You don't need to write so much of code. Okay, I will go back to my slideshow to explain few terms. Okay, so we have these two terms that I told you that I am going to discuss. First one is vectorization. So it describes the absence of any explicit looping, indexing, etc. in the code. So we have actually already done vectorization with A3 equal to A1 plus A2 I have written. So my purpose is served, but I did not write any for loop or index positioning to equate the values and to make the summation individually. Okay, so I have avoided all the looping and indexing. Then vectorized code is more concise and easier to read. Of course, means earlier you have written matrix addition with list and in other languages with simple array in C, C++. So it was lot of code you had to read and you have to write, explain. But here it's very simple, only A3 equal to A1 plus A2. Fewer lines of code generally means fewer bugs, of course, as it is a very simple line of code, so it is almost bug free. And if you write a code with some for loops for all the dimensions of the matrix, then it becomes complex and more error prone. The code more closely resembles standard mathematical notation, like means because it's simply if A1 and A2 are only some scalar values, then also I will write A3 equal to A1 plus A2, and here A1 and A2 are actually two dimensional arrays and still I am writing the same type of code. Okay. Vectorization results in more Pythonic code. Without vectorization, our code would be littered and inefficient and difficult to read for loops. So Pythonic code means Python, the principle is it should be always efficient and it should be very easy to read and write and understand, right? So all those things are actually fulfilled to vectorization. So the thing we have done so far, it is vectorization. Okay, I will show some few examples. And then the another term that is called broadcasting. Broadcasting means is implicit element by element behavior of operations. That means when I am writing A3 equal to A1 plus A2, so actually it is getting impacted, the entire matrix, all the elements of the array are getting impacted. So it's kind of a broadcasting. Broadcasting means that when I say something, then it is actually reaching all the people in the entire network. So it's also the same thing. When whatever operation you do, it is actually reaching and it is actually getting implemented for all the elements of the array in scope. Okay, so I will go back to Jupyter again. So I will go to the next block of code. Here I have written that I am printing a2.sum. So a2.sum means it will actually summarize all the elements of the array and it will print. So if I want to see it differently, so I will add one more cell here. I will just cast these things here and I will print this part. So if I execute, so you can see 26 means it is actually 5 plus 6 means 11, 11 plus 7, 18 plus 8 means 26. So it's the addition of all the elements 26. Okay, and then I have written A4 equal to A2 into 2. So A2 into 2 means what? Actually I have written only I am multiplying this. So what I want to do, I want that all the elements of this A2 should be multiplied by 2. So if you just print this, you will see, you can see it is 5 into 2 10, 6 into 2 12, 7 into 2 14, 8 into 2 16. So this array is now changed to this because all the elements are multiplied by 2. So this feature is actually broadcasting, means here whenever I am doing any operation, it is actually implemented on all the elements of the array. Fine. Okay, few more functions. So here I have created one array A1. Now you are clear on this thing. So I am taking this arrange function it is taking the elements from 1 to 4, means 5 will be excluded, so 4 elements, and I am just reshaping it to 2 by 2 array. Okay, then I can print the max element of that array, mean element of that array, and I can transpose the array as well. So transpose is a function which just change the direction of the elements. So if I execute this entire thing, so you can see the maximum element as the array formed with 1 2 3 4 values. So of course max element is 4, mean element is 1, and this is the transposed array. So for I have printed both A1 and A2. So this was my A1, which is 1 2 3 4. So as you know, in transpose the index position changes. So here you can see that it has become 1 3 2 4. Okay, so the rows have become columns and columns have become rows. So 1 3 were columns, now 1 and 3 are rows, 3 4 were rows and they have become columns. So this way it is changed. So I feel it is clear, and actually there are many more functions, but I have tried to cover whatever is important for you to start working with Numpy. Okay, so that's it for this session, and we will be back with another topic for our session. Thank you very much.